Hi, this is the challenge one for programming in PLC and Logitech in Digital Twin. We are Leonardo Andrés Pacheco Carrillo, Leonardo Fabio Mercado Benítez, Michael Alexander Rodriguez Urbina, and we are mechatronic engineering student. Our teacher is Eduardo Barrera Waldron, and this is for the course SCADA and Industrial Controllers, Faculty of Engineer, Mechatronic Department, Bogotá, Square, 2021, National University of Colombia. For this challenge, we use Logitech Emulate, which is a software that allows us to virtualize Allen Bradley PLCs, with which we can simulate all behavior of a PLC in our computers. We also use Studio 5000, which is the software with which we program our PLC, and we use RSLink as a OPC server to handle the OPC communication between the PLC and the digital twin. Finally, for our digital twin, we use the Factory IO software, which allow us to virtualize the conveyor boxes, actuators, and sensor, which are managed by the PLC through OPC communication. Okay, next we present the engineer logic implemented in this challenge. We start at the step 0, applying a safe logic to start the process. As you see, we have the start and kn1 tags as output. We apply the interlocking of kn1, and we must remember that the physical stop button is normally closed. On this step, we get the subsequent step permission to operate. In the step 1, we have if kn1 is on, there is a startup, and at buffer exit is on, there is no bots at the end of the conveyor, or if kn1 is on, there is a startup, and timer 2 done is off, and kn2 is off, it will activate the buffer conveyor. In the step 2, we have if kn1 is on, there is a startup, and timer 2 done is on, or kn2 is on, and timer 1 is done. If off, the center blade is activated. In the step 3, we see that the both process, the exit conveyor is activated, and it always remember activate. In the step 4, we see that if the sensor and the edge of the buffer conveyor turn off, the execution of delay on off tough timer 1 starts.
In the step 5, we configure the second timer to control the time required for the box to pass through the stop blade before the stop blade goes up again. After the timers are activated, we created a variable which represents if a box is in the second conveyor. It activates when the box passes through the stop blade and deactivates when it leaves the conveyor. This allows us to control the first conveyor and the stop blade in the process. The communications between the sensors and the actuators are configured thanks to the OPC server. To make the connections easier, we made sure that the tags created on Studio 5000 had the same names as the sensors and actuators on Factory IO.
This is the scene from challenge number 1. We have 3 present sensors, the first at buffer entry, the second at buffer exit, and at exit. On the other hand, the actuators are buffer conveyor, stop blade, and exit conveyor. Now we start the simulation. When the operator presses start, the boxes begin to appear. The buffer conveyor actuator is activated, and the boxes move until they meet the stop blade that prevents them from continuing to advance. Then stop blade is deactivated. The first conveyor is activated and passes a box to the second conveyor. The box that comes behind is detected by the at buffer exit sensor activating the stop blade. While the box that passes through the second conveyor reaches the end where it is detected by the add-exit sensor, and simultaneously deactivates the stop blade, activates the first conveyors and lets the next box pass. This process is repeated until the operator presses the stop button, which deactivates the actuators, breaking the entire process. Conclusions. Using virtualized elements allows us to carry out rapid development. In the same way, it allows us to carry out tests without any risk of accident or damage to equipment or human staff.